So welcome to this year Control and Perception in Networked Automated Vehicles lecture. At the beginning, I would like to mention that we are recording the lecture using Zoom, and we are trying also to record it using other programs. And for this, we have to show you the privacy. Now you can read it in German. I hope you can read German. If not, you can take it from Moodle and put it in some automatic translator. I read it today for the first time, but in the next lectures I'll just show it at the beginning. So für den Datenschutz, die Lehrveranstaltung wird heute aufgezeichnet. Sie sind verpflichtet, Ihr Videobild, Ihren Audioton oder andere personenbezogene Daten wie einen Klarnamen oder ein Bild von Ihnen zu übertragen. Die Übertragung von Video und Audio ist für Sie aktuell deaktiviert. Wenn Sie nicht Teil der Aufzeichnung werden möchten, aktivieren Sie die Übertragung einfach nicht. Wenn Sie hingegen einverstanden sind, Teil der Aufzeichnung zu werden, lesen Sie bitte vorher die Einwilligungserklärung und die Informationen zur Verarbeitung Ihrer personenbezogenen Daten sorgfältig durch, die vom Moodle-Lernraum erreichbar sind. Wenn Sie dann Ihr Bild, Ihr Video oder Ihr Audio einschalten, willigen Sie in deren Aufzeichnung gemäß Einwilligungserklärung ein. So, damit beende ich diese Datenschutzerklärung. So, I will, where can I do it? Hier, Präsentation beenden. So now we will start with the lecture. So, yeah, I try to look into the camera so you can see me. Yeah, we will start with an introduction. The introduction will take this lecture and probably the next lecture. So we will start with, I put the mouse to the side, right? So we'll start with an introduction of ourselves. So my name is Bassam. I am the head of the group CyberPhysical Mobility, the chair of embedded software. I'm working here since 2017. Before, I was in the mechanical engineering department, also at RWTH, and did my PhD there in control engineering. Before that, I studied computer science and automation. So due to the COVID-19 pandemic, this lecture is going to be completely digital. And I'm now in the office, but you cannot see me in the office. So if you would like to speak to me, please just email me and we will find an appointment in Zoom. So now I would like to hand over to Patrick to introduce himself.
Yeah, hi, I'm Patrick. I work at the Institute for Embedded Software since last year in March, I think. I graduated in mechanical engineering and automation technology. I don't know, Automatisierungstechnik, automation engineering.
Right.
Yeah, so I'm mainly responsible for all the organizational stuff around the lecture and also the lab at the end of the semester. So same as for Bassam goes for me. So I'm sometimes at the office, but yeah, best is to get in touch with mail and then we can talk via Zoom or something.
Okay, now some words about Zoom. I hope you're familiar with Zoom since last semester, but I'll mention some important things. So you see at the bottom time namer or participants if it is in English. And if you click on it, you will see a menu in the bottom. And in this menu, you can, for example, okay, I cannot find it right now as a participant, but however, you can raise your hand, give a thumb or whatever if you have a question. So if you have a question during the Zoom session, please let us know that by raising your hand. So Patrick will be the moderator of the lecture, and he will interrupt me if you have a question. So additionally, we have also a chat. If you would like to tell me or tell Patrick something, please put something in the chat. Now I see somebody has posted something in the chat. If it is interesting for me, Patrick, you should interrupt me and tell me what is the matter, but I am not going to read the chat during the lecture. I cannot, so I am not multitasking. I cannot speak and read at the same time. So what else to tell about Zoom? Yeah, at the bottom you see also audio and video, and there you see an arrow. If you click on it, you can select which microphone, which speaker, and so on to choose for communicating via Zoom. What else I would like to mention about Zoom? So the view I like in Zoom is to maximize the window and to see the participants on the top and the slide in the main window, and on the right I see the participants and the chat. So play with Zoom, find the view you like. So I hope you hear me very well. If not, just raise your hand. So I will start with a short introduction to the chair we are now working. So here we see a photo just before the pandemic started from a colloquium. Each year we go for group presentations 2 times, in summer here nearby to the Eifel, and in winter to climb Bassam. It is in the mountains. And yeah, in the next slide I'll show some facts about the group. Our head is Professor Stefan Kowalski, and we have around 20 researchers. Our researchers are from computer science mainly, but also from other disciplines like mechanical engineering, especially automation engineering, electrical engineering, and so on. So I think it's enough. You can read the other facts if you are interested, or go to our website. So I would like also to introduce the research groups in our chair. They are formal methods headed by Markus Völker. By the way, in this term, Markus Völker is going to offer also a course for master students in computer science and automation engineering. It is about of course, formal methods. So, and the group do research about verification of cyber-physical systems, and they apply their research to industrial automation. We have also a small group now working on model-based design, especially for automotive software. And what we do is test support, test management, mainly. So we have also a biomedical systems group head by Andres Stollenberg. In this term, he's not going to offer any courses, but in next semester, he will offer a course about advanced microcontroller programming. So in the group, they do mainly supervision of medical devices and data analysis for biomedical systems. For example, now for the Corona pandemic, they are working on a ventilation device. So I am also part of the development of this device. It's called PV1000. If you Google for it, you can find it. We have already a website, PV like ventilator. So we have also the CyberPhysical Mobility Group. It's headed by myself, and we do mainly network control systems and service-oriented architectures. And in this course, we mainly focus on the aspect of network control systems. So now we see an overview of the lectures or of the courses in general offered by our chair. They are, I start at the bottom in bachelor. It's not more interesting for you. Maybe you participated in it. It is Technische Informatik and Praktikum Systemprogrammierung. If you study computer science, you have done these two courses. In the specialized courses, we offer embedded systems. In summer, we offer functional safety and system dependability. So embedded systems is also in summer. So now, in parallel to this course, we have formal methods for logic control software. Microcontroller programming and debugging is also in summer. And this course is control and perception in networked and automated vehicles. So you can do also scientific work in our chair. Maybe you have already done some pro seminars or seminars. You can do, okay, you are in masters, maybe you have done your bachelor thesis with us. I know at least one participant or two who did their bachelor thesis with us. So you all are also invited to write your master thesis at our department. We have also a lot of HEVI and BHE jobs. Our group offers also a course named CyberPhysical Mobility Lab. It is for bachelor students. It is a practical course. In German, Software Projekt Praktikum. We have also a student group participating at a competition named Carolo Cup. In a minute, I'll show a slide about it. And also we have a practical course named Automated Distillation, which will not, actually it is usually in winter, but due to the pandemic, we will skip this term. So now I'm going to present the group, CyberPhysical Mobility. And here we see, of course, a photo of group. So for the group presentation, I have to leave this PDF document, Vollbild verlassen, and go to a presentation. So I hope it will work. So the group members are 7. We work a lot with students, and we have also the student team participating at Core Camp. It's named Galaxis team. So in the group, we combine 5 disciplines in mobility for developing algorithms for networked and autonomous vehicles. You read here the word autonomous, and in the lecture you have read the word automated. So during the lecture, you will learn also about the terms automated and autonomous. So our projects are funded by public organizations and commercial partners. So the topics in the group are control engineering, mathematical optimization, communications, and these 3 parts are part of this course. We do also research in the area of software architectures and verification of safety. In this course, we use it just in, or we are going to use it in the lab work. What we are going also to offer is 2 lectures about perception systems. So stay tuned for it. It will be in the beginning of next year. So yes, you see a list of the projects of the group. Yeah, I'm not going to read the list of the projects. Just go to our website and you see more about it. I show some slides or some results from research to motivate this lecture. What can you do if you have participated in this lecture? So here we see 2 applications. On the left-hand side, we see a road intersection where vehicles are networked and, of course, autonomous, and I have to pass the intersection as fast as possible and safely. So we say efficiently and safely. On the right-hand side, we see an application named Go-To Formation, where vehicles start at arbitrary positions and orientations. Their mission is to go to predefined goal positions and orientations. So the 2 methods on the right are centralized and distributed computations, which you will learn in this class. So the next video is a racing of 8 vehicles around the Hockenheim Ring. So this is an exciting application, because here we are dealing with a network system of vehicles where we have 2 goals. One goal is to be as fast as possible, to be time optimal, and the other goal is not to collide with each other. So the vehicles have to compete, but at the same time to cooperate. So here we see some pictures of vehicles from another project. It's named Unica Agile. You can go also to the website. What we are doing in this project is we are developing a software architecture. It is service-oriented software architecture. For details, I would suggest that you go to our website. So the special thing about this architecture is that we also apply it more or less in the lab. So you will also deal with a service-oriented architecture. So in our projects, we also have a project where we improve localization using infrastructure elements. We have also a project where we enhance safety of pedelecs by detecting dangerous driving situations. And here you see a video of the CyberPhysical Mobility Lab, where you will work at the end of the course. So here we see 9 vehicles driving around the plane. The lab is around 6 by 7 meters, and the plane is around 4 by 4.5 meters. The outer ring is or should be or should model an autobahn motorway, and in the middle we see a road intersection. So the vehicles have to cooperate to drive efficiently around the autobahn and the intersection. They have exits and entrances to the autobahn or from the autobahn. So why I am showing this video and the other videos, it is more to motivate you that after this course you will be able to implement algorithms for network vehicles to be able to drive like in this video, for example. So I promised to show a slide about the Galaxis team. So it is an interdisciplinary student team. As our group also, it is interdisciplinary. So currently we have 5 students in the team, and they develop an autonomous vehicle around has a scale around 1 to 10. And what you learn in Karolo Cup, what you develop is sense, plan, act. So the vehicle has to sense the environment, has to plan the next actions, and have to act on the actions. So we were 2 times at the first place, and 3 times we were runner-up. Due to the pandemic, the Karolo Cup is going to, or the organization team is going to skip it in 2021, and the next one hopefully would be in 2022. We are working with our team to, with the goal to win the Karolo Cup in 2022. So if you are very motivated and have time, so please let us know. So for education, I have already showed these 2 lectures. Now you are in the lecture or in the course Control and Perception in Network and Autonomous Vehicles. So here you see some information, also the links to our websites. So beibehalten. So here you see, if you go to the website embedded.rwth-aachen.de, you will find the website of the chair, and if you go to CyberPhysical Mobility Group, you will find a description of the group what we do in the group, and you will find some aspects of the lecture also in the research projects we're conducting in the lecture, in the group. Sorry. So now coming back to our introduction. So now it's your turn. So what I would like you to do is just shortly introduce yourself. I'm excited to get to know you. So please mention your name, study program, semester and master program. And I'm very excited to know your motivation to participate in this lecture or in this course, and your expectations about it. So in general, I would like to motivate you to turn on your cams every time we go in discussions. It is really much better for me to see your faces. If we would be in the classroom, I would see you. Everybody would see each other. So you're not forced, of course. You can choose if you would like to show your cam, but during when I'm introducing the lecture, you can turn off everything what you want. But if we go into discussions, we will go also into discussions in groups, in breakout sessions. So you will be in student groups of up to 5 members. And I think for the communication, it's very good if you would also turn on your cam. It's of course up to you, but for me, it's much better than speaking just to a screen. You have to try it. It's it's strange. If you are used to speak to people and at once you're speaking to a screen, you have to get to it. So I'll share my screen again. So I was very happy to get to know you and your backgrounds. Maybe I not remember every face and every name after this lecture, but with the time, I'll hopefully remember you. So screen sharing. So you are looking again to my presentation. Why it's not working? So the next part is the lab visit. So unfortunately, we cannot do it in person. So we have to do it virtually. So this is the lab. So I have described the lab during the video a little bit. And the lab consists of hardware and software. In the hardware part, we have the MIU cars. They are model scale vehicles of 1 to 18. It's around 15, or Patrick, you know it much better. How long and how wide?
Like 20 centimeters long and 10 centimeters wide.
Okay, thank you. So the vehicles we took the mechanical design and changed it to be autonomous and networked. So you will learn in the lab how we did that. And if you are interested to know it now, just go to our lab website and take a look at the video. We will, in a minute, we will go together to the website and look at some parts of the website. So we have also to localize these new cars on the plane, and for this we use a camera. The camera detects LEDs mounted on the cars, and we have per car 4 LEDs, 3 LEDs to detect the position and orientation, and 1 LED to detect the ID of the vehicles. It flashes in a specific frequency, and we have different frequencies for the vehicles, so we can use the camera to know which vehicle we are now detecting. And we have a main computer. It is the computer where we run the experiments, where we control the whole lab. It's called also Lab Control Center. Actually, the Lab Control Center is a software running on the main computer. And also for distributed computations, we have a computer, a small computer, the MUCA. The computers are not mounted on the cars, are in a server trunk in the lab, and they are connected to the vehicles using a router, wireless router. So what we are working right now is a remote access, and the first or second level of the remote access will be experienced by you. So in this semester, we are offering a software practicum in the lab. The students will work from home because of the pandemic, and they will, the first group working with the lab and not being in the lab, and you will the second group. So you will get a simulation environment from us, and you will work in this simulation environment. You will develop there your software. You will upload your software either using the web access website, if it is functional to the time where you work in the lab, or you will send it via Moodle or whatever, and we will conduct the experiments here, record the videos, and send back to you, so you can experience the lab remotely. Now I will go for a virtual lab visit with you on the website of the lab. If you type cpm.embedded.rwth-aachen.de, you will get to our lab website. So here on the main side, you see the video I've shown in the slides. If you go down, you see the lab is placed between simulation and real world. So the main motivation of building this lab is to quickly see your ideas developing into reality. So to see your software in action. So if you scroll down, you will also find the picture I showed on the slide, and a description of the parts of the lab you saw on the slide. yeah, if you scroll down, you would see our funding partners, and we have also a Twitter account where you can see the newest news of the lab. So if you go to the lab setup, you would find more details about the lab. For example, the lab architecture, how the lab is built, and this I hope you're not seeing my cursor. Okay, this picture you will see very often in this course. So and here you will find the hierarchy of the software in the lab, which you will learn also at the end of this lecture or at the beginning of the lab. So if you go down, you find a YouTube video. You can also watch it. It is, yeah, in general about the lab and how to control the lab. So I'll skip it and go to the lab control center. This is the main software running on, okay. Lab control center. So, it's running on the main computer, and you see the visualization here that you can select real and simulated vehicles, for example, how the deployment works. We have also diagnosis to avoid crashes in the lab. And here you see what we are working on right now. So some parts of the lab are still in development. So and we have the MUCA itself. It is the moving part of the lab. Here you see some description about it, and here an animation. If you scroll down, you see the hardware architecture of the MUCA, and if you scroll more down, you will see also a YouTube video describing the vehicle in detail. So you will see also a nice animation did by a student in our group. So I would suggest that you take a look at the videos. So if you go to CPM group, you see our group, resources, publications. So you will see the scientific paper we have written about the lab, and also you will find education. So in education, okay, I have to go to, no, should work. Okay, I don't know why it's not working, but yeah, you see our courses, and if you go to course materials, which is also not working on this computer. So I'm using a pen on this computer, so it's not a mouse. I don't know why I can't click on it. So just go to it, and you see a documentation. So we have also an open documentation of the lab. If you go to GitHub, you will find also the software of the lab. We published it completely. Yeah, and if you click on remote access, you will just see it's under construction. So now I will go back to the presentation. And before continuing, I would like to ask you if you have questions. Just raise your hand if you have a comment or a question. Or just turn on your microphone.
I have a question.
Go ahead.
No, it doesn't work. Can you hear me?
Yeah.
Okay, yeah, because I'm on 2 devices, so I'm kind of confused.
Okay.
Yeah, so my question is about the lab work. How is it planned to be working? Like, or do we have different topics? Each group is doing something different, or are we all doing the same thing? And yeah, do we have like frameworks or programming skills that are needed for the work and so on, like the general questions?
In a minute, I will speak about the course logistics,
Okay.
and I also speak about the lab. But to give a short answer to your question, all teams will develop the same application, but of course you have the freedom to develop it using your skills, your methods, and yeah, but you cannot copy the software from each other. I'll show in a minute why.
Okay.
So, other questions? So I see messages in the chat. Is something relevant to me, Patrick?
No.
Okay, then go ahead. So the RWTH got 150 years old some weeks ago, and yeah, here we see a picture of Shari Reeves. I think you know her, or most of you know her. She is a famous moderator in German TVs, Der Sendung mit der Maus or Wissen macht A. And she interviewed me about the CyberPhysical Mobility Lab. And yeah, our part you can find in this video. So if you go to our website, you can click directly on the link, or when you get the slides, you will have also the link there. You can click on it. So now going to the course logistics. So as I presented, the course contents present or represent the work of the group. So if you participate in this lecture, you are prepared to do further works in the group. So what we are going to learn in this lecture. So we have the point vehicle models. So this menu, okay, cut right off the menu. So you will learn some dynamic vehicle models. After the basics of vehicle dynamics, we will go to basics of control engineering and optimization. So I know some of you have strong background in control engineering, especially if you are studying automation engineering. Some of you have, let's say, less background in control engineering, especially if you're studying computer science. So I will try to get you to the same level in this course to be able to work together. So in optimization, it depends what you choose in your study program. If you are studying computational engineering science, I think you have learned a lot about mathematical optimization. If you're studying automation engineering or computer science, it depends on, for example, in computer science, it depends on your Nebenfach. So then we have the here part of the course. The core part of the course is network and distribution, and so it's the really exciting part of the course. So I would suggest if you if you get somehow bored during the course, just try to stay motivated, and I am sure in the part of network and distribution you will be very excited. Then we will have 2 courses or 2 lectures about machine perception. Of course, machine perception is a huge topic. You can go to many courses on it. But in this course, we're going just to give you an introduction to the topic. So then we will have some work on software architectures and testing concepts as a preparation to the lab work. So we're not going to teach software architectures deeply here. If you would like to learn more about software architectures, you have to go to E3, Professor Rumpel. So then we will have some practical work in the lecture as a preparation for going to the lab. Some case studies directly in MATLAB or Simulink. So I'd say in a minute some words also on MATLAB. So the course materials will be posted on Moodle as soon as I finish the slides, or as soon as I have the materials ready to upload. You will find them on Moodle, most probably a day after each lecture. So the lab will allow you to apply techniques on real model scale vehicles. So after learning the let's say the methods, you will be able to apply them to the lab. So here you see some literature. So I go rapidly through the literature. The first one is on vehicle dynamics and control. So I tried to cover the course topics each by a book. So the part of vehicle dynamics is covered by vehicle dynamics and control. The second book is about control systems. But if you are familiar with control engineering, or if you feel you have got enough knowledge about it in this course, you don't need to go to this book. You can also use other sources, of course. But I've just mentioned here one famous book about control systems. There are also many. If you are studying computational engineering science or automation engineering, or computer science with Nebenfach Maschinenbau, you have participated or going to participate in the course Control Engineering, Regelungstechnik, and the course is enough, and the script you get there is also enough for our course. But the third book is Convex Optimization. It is also you find many resources about optimization. This book is the most famous book about optimization in the engineering applications, let's say. So the third one is about predictive control with constraints. It is this book combines control engineering and optimization to predictive control. So you will not have to read the book completely. I'll give you some parts of the book to read. So the next one is about state estimation. So it is just to complete the list. It's also a famous book about state estimation. The next one is about network systems. So if you participate in this course, the materials you will get in this course is enough. If you would like to deepen your knowledge in network systems, this is possible using this book. So the last one is about rapid control prototyping. So if you have participated in embedded systems, it's also enough to know about testing. So what you need from a rapid control prototyping is more the testing part. V model, hardware in the loop, software in the loop, and so on. If you already have participated in this course, if not, don't worry, we'll teach you the important parts. So some of the books are available in the University Library, UB, Universitätsbibliothek, some in Adobe digital editions. So if you go to the website of the library, maybe I can show it shortly. So I don't know, maybe this is the library. Yeah. So it's not working on my tablet. So don't worry about it. Just go to the library, put the names of the course, and you will find some of them directly online on the library website. And for some of them, you will need a software named Adobe Digital Editions. You can also download it directly there, and it is also for free, and you can read the books. So should we start with it or postpone it to the next lecture? What do you think, Patrick? Maybe we postpone this slide to the next week.
Definitely the discussion of the results you won't be able to do probably, but
yeah. I'll just take a look about the next slides just to decide if we do this or if we go ahead. So I would prefer to do it in the next lecture. So yeah, we have already mentioned the participants are from the 3 study programs, and what you need is you should be in masters. You are already, and you should be interested in network and automated vehicles, and you should be also interested in experimental work for the lab part. So the most important slide in this course is this one. So the lecture style. This is not a traditional lecture. It consists of different parts. One is the presentation, what I'm doing right now, and what we mostly did in today. What we are going also to do is flipped classroom or inverted classroom. So in flipped classroom, I will shortly introduce a topic. You will get a week to prepare by reading or watching videos to prepare the topic. And in the next lecture, you have to present what you have learned. So we'll divide you into 5 groups. No, 6 groups. 5 groups. You will be divided into 5 groups, and I'm planning to have 5 flipped classrooms. So each group will have the opportunity to prepare 1 flipped classroom. So in the groups, you will work in teams of 2 from 2 different study programs. So a team of a group will present the topic. So maybe I'll explain it in more detail, just this point. So this is the classroom, and in the classroom we have divided you into 5 groups, right? And each group consists of 6 people. So 6 students are in 1 group. So 6 by 5 are 30, the number of the participants in this lecture. So we limited the number of participants in the lecture due to the lab work, because we cannot host more than 30 people in a term in the lab. And also limiting the number of participants allows me also to have this special lecture style. So in each group, there are teams of 2 people. Yeah. So I'm trying to draw, and we will have 3 of them. So we have groups and teams. So just a definition: a group consists of 6 people, a team consists of 2 people. And the 2 people here are from 2 different study programs. So you cannot work, if you study computer science, you cannot work with computer scientists. You have to work either with an automation engineer or computational engineering science student. So I hope this is clear. Now going back to the slide. So what also belongs to the lecture style is group discussions. So we'll discuss in the group. So we will send you to breakout sessions for a predefined time. For example, I don't know, 3, 4, 5 minutes. And we will get you back to the main room where we will discuss your opinion about a topic, or where you present what you have discussed. So what we also will have in parallel to the lecture is practical exercises in MATLAB. We will not solve the problems we give you in the lecture. We will just offer the problems and solutions. So for MATLAB at RWTH, we have a campus license. And for more information, go to the MATLAB website of the university. And if you are new to MATLAB, yeah, and in the MATLAB website, you find a script to a lecture on MATLAB. It's named Treffpunkt MATLAB. I think this course is completely in German. If you would like to read resources in English, just type MATLAB and course or something similar in Google, and you will find a lot of materials. So very important for this course. We will record, we are recording the lectures, but we will upload the recorded lectures only if a minimum of 18 students attend the lecture. So, and this slide explains why. This lecture lives from your participation. If you don't participate because we are recording the lecture, you're working against the lecture. And why and how this will work, and yeah, we will discuss this point more deeply when we go to network, because you students are also a network. So then, yeah, to the logistics, we will have an attendance list. You don't have to sign the attendance list because it is digitally, so Patrick will somehow get noticed that you are participating in this course. So yeah, Patrick wants to say something about this.
Yeah, so of course I noticed we don't require you to put your real name into Zoom, so this is kind of iffy. But so the intent of this is, of course, so this course is limited to 30 people, and if somebody takes a spot in the course and doesn't really want to participate, then it's kind of a bummer for the people who didn't get a spot in the course. So that's why we usually keep track of who is participating, and then we we mail the people who are not participating if they are certain that they want to take part in the course, or if they want to free up the spot for somebody who is more interested. So for example, for the two Linus people, if you would just put an extra letter for your surname, then it's easier for me to like text the right people to ask them if they are sure if they want to participate, which helps your fellow students in the end. So that would be great.
Maybe an idea also, if you would like to use a nickname here in Zoom, maybe it's an idea to say in a chat in Moodle who you are. So somehow let us know who you are. So yeah, next we will speak about the grading. In the lab, you will work with simulations. I have explained in teams of 2 students. Yeah, maybe Patrick wants to say something about the lab work. He is the supervisor of the lab work.
Yeah, so usually we do this in person in the lab. So what's really helpful, if what students found really helpful is that I was there to answer questions when they come up. So our substitution for this, since we have to do it in simulation, is that I will be I will offer consultation hours for 2 weeks. So I will be there for your questions. You can call me whenever during this time, and I will always be ready to answer any questions regarding the lab. So in the real, so if we had the possibility to be in the lab, everybody would have 4 days to do the lab work. So you can take this as an estimate of how long you will take to finish the work there. But you are free to choose your 4 days in these 2 weeks or whenever you want to do them. But in these 2 weeks, I am ready to answer your questions. Yeah, so after you finished your lab work, as Bassam already mentioned, we will test it in the lab and send you back the results. And then in the exam, I don't know, do you want to talk about the exam, Bassam?
Yeah, I can say some words. So maybe I would like to add to the lab. Actually, you are adults, you are in the master program, you're doing this course or participating because you are interested. So I assume you will develop your code by your own, but just for your notice, if you would use the code of other teams, yeah, and we would know it, it's not good for you. So we have yeah, a plagiarism check. Maybe if you are a computer science student and participated in PSP, system programming, you will know about it. So the exam is consisting of 20 minutes per student. You will have 5 minutes to present your lab work using the video and some predefined slides. And then I will ask you around 15 minutes about the lecture, maybe about the results of your lab work. Yeah. That's all for today. So we have now 4 minutes more. So I would now like to thank you for your participation today. I'm happy to see you next week. And if you would have questions, just stay here in the Zoom room and we would be happy to answer your questions.